Everyone, thank you for coming. So unfortunately, the speaker that was supposed to give this presentation is sick and is sending his apologies, but is unable to be on stage. The talk we have been experimenting with a Kotlin compiler, and that's really unfortunate. But we found a volunteer that took over the slot. So we're going to have Geoffrey on stage talking about modern asynchronism with coroutines. Thank you very much.
Good morning, everyone. So I just presented the coroutines in the most generic way I could because I am an Android developer too. I'll do a second talk this afternoon at 1 p.m., which will be more specific to Android. So I won't cover everything for Android right now. You can come this afternoon for almost fill it up. First of all, I'll present myself. I work at Video Labs, which is a company founded by Videolan people to have people full-time on VLC. So I work on the Android port of VLC. So, long story short, coroutines are just the Kotlin compiler wrapping the callbacks for you. So, do I have to speak louder or is the mic?
There you hold it like that next to you. Try.
Okay. Is it better? Yes, I am. Coroutines are then just under the hood wrapping callbacks for you. So the compiler you will write linear code, sequential calls, and then the compiler can do some callbacks for you, and you don't have the callback. Usual callback helps when you do some asynchronism. So you don't need to lock and you don't need to write callbacks, and you less need to block the current thread. You won't use mutex anymore or semaphores. So the paradigm now is suspending instead of blocking a thread. So we have a suspending function which frees the current thread, which is available for the task, and then we'll call back later. So the entry point of coroutines is the launch call. Usually, it returns a job, and the job is the controller of your coroutine. You can specify a dispatcher which will decide on which thread will the coroutine execute. The second most useful is the with context. So inside a coroutine, this will suspend this coroutine and execute the inner code in the context you specified. Here, I chose to use dispatchers.io, which is an IO dedicated thread pool, to do a background IO operation, which will be blocking. So during this time, the main thread is free. It can just continue to display your app. You can still have inputs from user while the file is being fetched. And once the file is ready, in this coroutine, we come back to the main thread when it's available, and we continue our task. There is the async call, which mimics the async await from C#, which is more suited. It works a bit like with context, but it's more suited for parallel calls you need. So here we can call two async tasks, two different async tasks, and then await for both of them. So this way, we'll have two parallel jobs launched, and once they are both ready, we can just leverage the result. This in Java would be complicated to achieve. That would be a lot of callback else, actually. And this becomes really, really simple with the coroutines. So here the catch is the dispatching. You'll see the code is way more simpler, but under the hood, you have to get in mind that the execution is not a call stack anymore, like in a regular function. So it's not, you don't know the exact state of your thread, potentially. Typically, when you start from the main thread, you do a with context background task. When you come back to the main thread, everything can happen. Maybe the view has been just wiped in the meantime and the task is not valid anymore. So this is the trick we have to know with coroutine. It simplifies the code, but under the hood we have to know that, like with regular threading, we don't know the state of the calling thread, the original one. We can also specify when we launch a coroutine to not dispatch immediately, because by default we just post the call to the main thread, which will be executed later. So we leave the current function. And that's it. So for the Android developer, the main dispatch, the dispatches.main implementation is based on the handler. It's just simply posting a runnable to a handler. When we launch a coroutine, I showed you we chose a dispatcher, but actually we can specify more complete context. And context will be with the most important element are the dispatcher and parent job, and we can also specify exception handler and name. So dispatcher will just decide where the code will execute. Job is an interesting feature that it will be a controller on your coroutines. So we can join this job like we join a thread in C++, for example, and we can also cancel it. And coroutines can have a parent job. That's what we specify when we launch it. And if you cancel a parent job, all the children coroutine will be canceled too. And that's really powerful to cancel operation when a specific scope is not valid anymore. That's why JetBrains implemented the coroutine scope interface. This is basically just a holder for a coroutine context, but it will create the pattern of always specifying a coroutine context and matching to a life cycle. So when you have a session, you can define the scope, the coroutine scope matching this session, and when the session is over, you cancel your coroutine scope, which will in fact cancel the parent job you are affected for every coroutine. So all of your background and waiting tasks will be automatically cancelled when you decided this is no longer valid. There is a global scope which is not deprecated, but it's not advised to use it. But this is full for migration from regular Java code to Kotlin. So this is how we match coroutine scope to a life cycle. This is an Android view model which has its life cycle. It is created, and when the corresponding view is definitely destroyed, it will be cleared. So here we just define a parent job, the dispatcher we want to use, so this is the main one, and then on clear we just here we cancel the job and we can call the scope.cancel call, which is just a shortcut to this. I wrote a regular job, but there is a variant, supervisor job, and supervisor job will not cancel when one of its child fails. In the former example, with the two parallel async calls, with a regular job, if one of these calls fails, the entire scope is cancelled. This is convenient when you really need the two results. For example, you don't care about waiting for the second one when one has already failed. In most main thread tasks, you want to use a supervisor job, because if one task fails, you don't want to end abruptly stop the user experience. So on some notes, coroutines are very powerful, but it breaks the interoperability between Java and Kotlin. There is a mutex class which works really like the normal one, but it doesn't block, it just suspends and it has to be executed. So in a coroutine context, there is a volatile annotation in Kotlin, which is quite useful too. It just matches the Java volatile. And that's it. And so now I'll just show you some some way to use this coroutine to do some really cool stuff and more complicated one in a simpler way. The first one I'll show is the callback limitation. We'll wrap a multiple shot callback in a coroutine. So in this example, I took the libvlc browser API, which is an asynchronous browsing API. So we just tell we want to browse this folder, and then we have callbacks for every media discovered, and one callback once the discover is over. So in practice, we have to define listener, which will receive the callback then. And so for a refresh, we have to start this discovering, and the listener will continue the execution. So we have the function occurring in two different places. So in Kotlin, we have channels. Go developer should know this. It's really convenient. We can just post events and wait for receive them. And here, this is what I use. I just define a channel, the callbacks will just post on it, and then when we want to refresh, we will use this channel, we'll initiate it, and use it to just suspend. We start the request browsing, then the for loop is it's a select actually. So this select will just suspend the function. So the current thread is free. Function is suspended, and every time we receive a media from the background task, it will just execute, and we can add our media in the main thread right when they pop. And then we can update our dataset in the data meant for the UI. And then it brings some nice addition. We have some operators like a map if we need some transformation when we have our raw media before sending it to the UI. We can also wait to have the full list, so we'll wait for the browse end being called for the list to be ready, and once we have that, we have the full list ready. Channel as being, that's an experimental API. So this is production ready, but this API may move like the actors. Actors is basically a simple wrapper on top of channel. The first example is for adapter. The way we're working is basically we post a list of elements to it, and it calculates the diff exactly like Git does between those two to update the view. So we have to send the update function. Will just receive the new list. We send this list to an actor, which is under a channel. In this way, I chose a conflated one. This way, if we send like 10 lists at once, the conflated will just ignore the intermediary step. So while the first one is being processed, the 9 other arrive on this, and every new one will just override the former. So in the end, we'll just process the first and the last ones. For UI, we don't care about just updating that much steps. We just want to be up to date. And then, so in this channel, we are in the scope. So we are kind of suspending function. So in this suspending function, I do the calculation in the default thread pool, which is thread pool with as much thread that you have CPU cores. And then we come back to the main thread to post events. And then we can process the next one in the list. So it's a queue of events which can be suspended. Another way of using actors is to confine mutability. That's what we do every day with the UI thread or main thread. So typically views cannot be modified outside of this main thread because of possible concurrent access. So the mutability of the UI is confined to the main thread. We can do this with an actor, so we confine it in this specific coroutine. So as this is a queue, it guarantees we cannot have multiple access at the same time. So here I can do like deletion, modification, and read access safely. This is just queued. It's not immediate, but this is guaranteed to not be concurrent, so I don't block anything. I don't need to use a mutex. I just confine it in this actor. So here I just use an unlimited capacity, for example, to not conflate and not ignore elements. And then I just have to post elements to this. Another example of matching the scope with the lifecycle. This is the view lifecycle on Android. It's right what I showed you sooner. I use delegation for implementation on Android, so I implement the coroutine scope with the main scope function, and I just now have to call the cancel in the onDestroy, and this allows me to use coroutines in this view, and all of the coroutine calls will be canceled when the view is over. We can play with it and add some useful extension function, like for any view. I can just use, this is an IODA function. We just post the action we want to do. We use an actor to stack the events to be processed. So this is a listener. The listener will post to the actor. This is automatic, and then all of this will be, as you understood, automatically cancelled when we don't need this view anymore. I'll show now another way to wrap callbacks, but single shot callbacks. So we just want one single event from a call. I took a REST call, for example. We just send a HTTP request and want one result. So this is how retrofit used to work, and now they natively support coroutines. So we had to make a call, and we add callbacks for the result. We can directly create a coroutine like this with the suspend coroutine, the suspend cancelable coroutine. It will create our callback in it, which will continue the coroutine with the correct result. Here are the important elements. So we call suspend coroutine. The call on queue is the call. The continuation is the state machine holding the coroutine states. So we either resume it with the result we had, and then this function will return the result with the correct type directly, or we failed and we return with an exception, and we can just try catch this call or use a coroutine exception handler, for example. So usage becomes pretty simple. We just have to wrap our API calls in this higher order function, and we get suspending function returning directly the correct type. Now, from this, I want to browse a path, so I just receive a list of files. And we don't care about this network logic anymore. We don't care about threading or whatever. We just have to be in a coroutine context. We call it, the coroutine will suspend, the main thread will be free from the time being, and then once it's ready, we have our data. A second example of the very same application in VLC, we have this is on Android TV, we have channels on screen. So we may have to start media before VLC being actually launched. So media library is not ready. I did the same implementation with a shortcut. If the media library is already ready, we don't care, we just execute the call. Otherwise, we do just what I showed you. We will launch a start call for the media library, and this coroutine will just suspend once the time for the library to be ready, and then we resume and we execute the call we wanted to do on the media library. This becomes really, really simple to use. It's been a very, very complicated case before coroutines, and this is now a single line of code to just get a media, whether the media library is ready or not. So thank you. If you want to know a bit more and more specific to Android, I invite you to come back at 1 p.m. And I'll present you the Flow API, which is quite new too. Otherwise, here are some links if you want to discover a bit more. And thank you for listening.
Other questions?
Similar question. Where can we get your slide?
Sorry?
Where can we get your slide?
Can we get?
The slides. Repeat the question. Where can they get the slides?
Ah, okay. I just had to prepare it really quickly. I post the slide URL on the FOSDEM the speaker. So you have it in the app and on the website.
Anyone else? Thank you very much.